All right, let's get right into it. If you're a .NET developer, you've probably noticed the landscape is changing, and fast. So today, we're going to break down a modern roadmap for what it really takes to be production ready, drawing on some brilliant insights from Vineet Sharma about how we should be thinking as we head towards 2026. And this quote, it hits right at the heart of the issue. We're always told you have to learn clean architecture, you need microservices right from the get-go. But what if that's actually the wrong way to start? What if it's slowing you down? Yeah, exactly. The whole point here is to bust that myth. We're talking about a totally different way of thinking, one that's all about mastering the fundamentals first instead of just memorizing complicated patterns that you don't even have a problem for yet. Okay, so let's start with this big idea, the myth of complexity. It's this belief that you need to know every single advanced concept before you can even think about building something real. And this slide just lays it out perfectly. The myth is you start with these huge abstract architectural diagrams, but the reality, the path that actually works, is starting from the ground up. You need to first understand how your code really executes, feel the pain points, and then, and only then, you let those real-world problems guide your architectural decisions. So where do we begin? Well, we start with the absolute foundation, understanding what happens when you press that run button. This is all about the magic of debugging and the power of asynchronicity. Come on, we've all been there, right? Sprinkling Console.WriteLine everywhere just to see what a variable is. It's painful. The modern .NET approach, though, is like having X-ray vision. You can set a breakpoint that only trips when, say, a customer's ID is a specific value. You can watch variables change in real time. You can use the call stack to literally rewind time and see the exact path your code took to get to an error. It's a superpower. And here's an amazing practical tip for right now. The next time you get a big, scary error message, don't just stare at it. Copy that stack trace, paste it into an AI chat, and ask it to be your tutor. Ask it to explain the story of what went wrong. This teaches you how to think like a debugger, which is way more valuable than just knowing a pattern. Now, async/await. This is probably one of the most misunderstood concepts. It's not about spinning up more threads to do more work. It's about efficiency. It's about not letting a thread just sit there, blocked and useless, while it's waiting for a database query to return. Async frees up that thread to go handle another user's request. And this diagram shows it perfectly. Your code is running, it hits an await, and the thing it's waiting for isn't done yet. So what happens? It doesn't just stop, it hands control back, and that thread is now free. Then, when the operation is finally complete, the code seamlessly picks up right where it left off. That little thread released box, that is the secret to building scalable applications. And here is the proof. Just look at these numbers. Your standard synchronous code taps out at 500 requests a second. But a well-written async API, it's handling over 5,000. That's a 10 times increase in performance on the exact same hardware. This isn't just a minor tweak. It's a total game changer for your application's capacity. Okay, so we've looked at how code runs. Now for the next critical step, taking that code and actually building and shipping something real. I absolutely love this advice. Your first goal is not to build a perfect, 6-layer, enterprise-grade masterpiece. No, your goal is to build one simple, maybe even ugly app that just works. Create, read, update, delete. That's it. Get something working. And yeah, if you look at that first simple app, it's got a million problems, right? There's no input validation, error handling's probably non-existent, and you're talking directly to the database from your API endpoint. Any software architect would probably have a panic attack looking at this code. And this is the most important part, here's what's so incredibly right about it. First, it works. Second, you can deploy it like today. And third, and this is the crucial bit, you will feel the pain. You'll quickly realize, man, putting my database logic here is getting messy. And that feeling, that real-world problem, is what will naturally drive you towards a better architecture. Because let's be honest, code sitting on your laptop is just a hobby. The real learning, the real experience happens when you push your code into the cloud. It might seem intimidating, but as you can see, there are really clear, simple paths to get your application running in a real production environment. And for that first ugly app, just keep it simple. Put it in a Docker container, which is like a standardized shipping box for your code,
push that container up to a registry, and then deploy it to something like Azure App Service. It's a managed platform, so it handles all the complicated server stuff for you. You just focus on seeing your code run live.
So you're building, you're deploying. Now you need to start working like a professional. And that means mastering Git, not just as a way to save your files, but as a tool to tell the clear, coherent story of your project. We've all seen this, and maybe we've all done this. A Git history that just says, fix, update, whip, another fix. It's a mess. Imagine 6 months from now, a bug pops up. How are you supposed to figure out what update actually did? This history is totally useless. Now this is the goal. A clean, linear history where every single commit is one logical, self-contained change with a clear message. This isn't just a log. This is living documentation. It tells the why behind every change, making the code so much easier for you and your team to understand and maintain.
And look, some of these Git concepts, like rebasing, can be a little tricky. So go back to your AI tutor. Ask it to explain the difference between a merge and a rebase using diagrams. Ask it for the pros and cons in a team setting. Mastering these tools is what really separates the amateurs from the pros. All right, we're at our final section, and honestly, this might be the single most powerful habit you can build for your entire career, learning to read professional, world-class code. The amazing thing is, the best .NET code on the planet is all open source. You can go to GitHub right now and read the actual source code for ASP.NET Core, for Entity Framework, for massively popular libraries like Serolog. You are literally getting free mentorship from the best engineers in the world. But don't just scroll through it. You have to be a detective. Ask why constantly. Why did they decide to seal this class? Why did they choose this specific data structure here? What difficult, high-stakes problem were they trying to solve with this piece of code? Understanding their reasoning is where the deep learning happens. So let's bring this all home. Being production-ready isn't about collecting buzzwords or knowing every pattern under the sun. It's about having a rock-solid mastery of the fundamentals. It's about understanding how your code actually runs, how to ship it to the world, how to tell its story with Git, and how to learn from the absolute best. So the only real question left is, which fundamental are you going to master first?